Okay, welcome to this special tutorial titled Polygon. So under Polygon, we'll be looking at the definition, some important polygons, the number of diagonals, the number of non-intersecting triangles of a polygon, the relationship between the interior and its corresponding exterior angles, some of the interior angles, some of the exterior angles, down to area of a regular polygon. So let's start. So the first thing is the definition. A polygon is just a figure or a shape formed by three or more intersecting line segments such that two segments meet at most two segments meet at a point, and each segment meet extra two segments. So see what I'm saying? If you have line, so this is a polygon because this segment 1, this segment 2, and this segment 3. So you notice that this is the intersection at most two segments intersect. So at most two segments, and each segment intersects additional two segments. So if you check segment 1 now, it intersected segment 2 and 3. But this is not a polygon. This is not a polygon because this is three segments intersected. So not a polygon. Why this is a polygon? So that's the definition of a polygon. Is a figure formed by intersecting three or more line segments such that at most two segments intersect at a point, and each segment meets other two segments. So we now move to title. Going to make it number of sides. Number of sides and the name. So we name polygon based on the number of sides. So the first one here is three-sided polygon, which is a triangle. The second one is a quadrilateral. So which is a four-sided polygon. The fifth one is pentagon. The sixth one is hexagon. The seventh one is heptagon. The eighth is octagon. The nine-sided polygon is a nonagon. And finally, the 10-sided polygon is called a decagon. So that's some important polygons. So the next one is the number of diagonals. The number of diagonals of a polygon. So you'll be wondering, what is a diagonal? A diagonal is just a segment joining two non-adjacent vertices. So assuming if you have a polygon, this is a four-sided polygon. Let's call this one vertex 1, vertex 2, vertex 3, and vertex 4. So if you join this V1 and V2, this is the diagonal, because vertex 2 and 3, V2 and 3 are adjacent to V1. So we can't form a diagonal by joining V1, V2 or V1, V3 because they are adjacent. So a diagonal is formed when two non-adjacent join. So that's what we call a diagonal. So here we can now derive an expression for the number of diagonals of a polygon. So if you notice, for this one, we have two diagonals. This one, this is the first diagonal. Why is this diagonal? So we have two diagonals in a quadrilateral. So this is the first and this is the second. So why this is a pentagon? This is a pentagon. So let's join. So we have 1, 2, 3, 4. Finally, we have, so we have total of 5 diagonals here. 1, 2, 3, 4, and 5. So non-intersecting diagonal. Sorry, we have 5. For a pentagon, we have 5 diagonals. So with this, we now notice something. Quadrilateral, we have 2 diagonals. This is 2 diagonal. So you notice that as we can generally derive the formula for number of diagonals, you notice that we have a total number of generally. We have, since the total number of sides is n, and out of it, let's use this pentagon to explain something. You notice that if this is V1, V2, V3, so we notice that we can use these 3, V1, V2, and V3, to form a diagonal, that are adjacent. So meaning that we need to subtract the 3 of them from what we have. And finally, we don't count twice. If you check, when I join one, that's vertex 1 and vertex 2 and 5, I didn't join 5 and 2. So you don't count twice. So we need to divide by 2. So n is just to show you that the total, that's the total number of sides times n minus 3. That n minus 3 is just to subtract the 3 for each vertices. For each vertex, we have 3 adjacent vertices. From the diagram, you can see that V1, V2, V4 are adjacent. V2, V4, V5 are adjacent. So this is the general. We have n times n minus 3 over 2 diagonal. So that's our formula for number of diagonals of a polygon. So the next one is number of non-intersecting triangles. Number of non-intersecting triangles. So what we have here, you notice that for a triangle, we only have one triangle, non-intersecting triangle, which is this. For a quadrilateral, we have 2 non-intersecting triangle. For a pentagon, we have three non-intersecting triangles. So you notice that if n is 3, then number of triangle is 1. Here, if n is 4, number of triangle is 2. Why if n is 5, number of triangles is 3. So what do you notice? There is a common thing here. They differ by 3, 1, 2, 4, 2, 2, 5, 3, 2. So generally we have n minus 2 non-intersecting triangles in a polygon. So that's a very, very important formula. So whenever you ask to find number of non-intersecting triangle, just use number of side minus 2. The next subheading here is the relationship between the interior and the exterior and its corresponding exterior angle of a polygon. So we note there is a very important relationship here. Assuming this is one part of a polygon, if I choose to extend one of the sides, we notice that we form a linear pair here. This is the interior angle, while this is the exterior angle. So you notice that interior angle plus exterior angle will always sum to 180. Linear pair postulates. So by linear pair postulate. So that's very, very important. For any polygon, if you add interior angle plus its exterior angle, its corresponding exterior angle is always 180. So the next one is the sum of the interior angle of a polygon. The sum of the interior angle of a polygon. So with this we use the number of non-intersecting triangles to get this, because if you notice if we have a triangle, we know that the sum of the interior angles are the sum of the interior angle is 180. If we have a quadrilateral, we have two non-intersecting triangles in it. So we have two triangles inside. So it's 360. This is 180. The sum is 180. Why this is 2 times 180, which is 360. If it's a pentagon, we have 3 triangles. So we have 3 times 1. So we notice that therefore the sum of the interior, interior angles of a polygon is always equal to the number of non-intersecting triangle, which is n minus 2 times 180. So this is a very, very important formula. So if you're asked to find the sum of the interior angle, just know the number of sides, subtract 2 from it, multiply by 180. That's the answer. So the next one is the sum of